Okay, so like I said before, that in the lab classes I want you guys to work, and I'll be around to check if things are going right or not. I want you guys to try this out over here. Some parts of it I've already done in our theory class, and maybe some of you have already tried them already. These were supposed to be done at home, but I want to make sure that you can do this. We were writing two separate classes, one for rational numbers and the other one for complex numbers. Right? So you can download our code from the Bitbucket repository. You know how to do this. I've already done so over here. I've actually pulled it, but you can also clone it. If it's for the first time, you have to clone that. And to get the repository link, you can just go to classroom.google.com, go into our classroom. Let me do it over here. Some of you may be new to this lab. So we go into our Java lab, and see, I've posted on February 5th that the source codes are posted over here. So you can go to this point. Oh, it's not going to work like that. That's the GitHub repository link, so you'd have to copy this link. And there are two things you could do. Once you copy this, you can go into NetBeans. You can go for team, and initially, if you don't have anything loaded, you'd have the option for team, git, and then clone. You don't see that now because I'm already in a project that's clone. So that's one way to do it. Or the other way, let me show this though. Like, let's say I go to my desktop and I want to download this whole thing. So I can open up a terminal, go to any location, and then I can run this command. It's already written out. So this is the command. I can copy from here and I can run this. And let me do this fresh. So for those of you who don't know how to bring in the terminal, just go to your start menu or just press start, and you'd have a dash and type in TERM. So you will have options for terminal. And then once you get this black screen or white screen or whatever color you got, then you can just go to any location like desktop or downloads, or even your home directory. But if you don't want to change, you don't have to change. You need to paste the entire code, and that will download things for you. Do not take this $sign though. This is to indicate that you're typing it on a terminal. Okay, like they have a $sign. So everything that's after the $sign, you can copy here. And when you hit enter, it will copy everything, all the code that we have written till this class. So once you have downloaded that, then you can go into file, open project, and then browse for the location. So right now I have downloaded that onto my home directory. So I can go into KM Hassan, and then I'd have a directory that says Spring 2018 Java, and the project that you're going to work with is this OOP demo. Is this thing clear? Okay. So I will do part of the code after you get a chance to work on it. But for now, I want you guys to try this out. Open up OOP demo, and then you'd find this code for rational number and complex number. See, the way it's done, we have the add method and the subtract method. This is something we have done in class, but I want you to try three other methods. One is multiply, the other one is subtract, and the last one is reduce. These things are obvious, right? Multiplying two rational numbers, then we will get another rational number. Divide one rational number by another rational number to get another rational number. The reduce, though, will divide the numerator and the denominator by the same number, and the same number would be the GCD of those two numbers. So we had a problem in class. If you remember, if you run this project, see, we got 10 divided by 3, we got 2 divided by 3, we tried to add them up, and we got, actually this is subtract probably. Let me look it up. See, this is subtract. So let me try with the easier example. So if you go for add, we are adding 10 divided by 3 with 2 divided by 3. The result we are getting is 36 divided by 9. But this can be reduced. You can go with smaller number to represent the same thing, with the same ratio. If you say 4 divided by 1, that would mean the same thing. Right? Then how do we know that this is supposed to be 4 divided by 1? It's because 36 and 9, they have the same common divisor as 9, and that's the greatest number. Like, you can also find 3 common over here. 36 can be divided by 3, 9 can also be divided by 3. But there is a bigger number than that. You can divide both these things by 9, and that's something we're going to do. Is this thing clear? How do we do this? How do we compute GCD? You may have studied that in C. If you haven't, just search for that on Google. You'll see many recursive implementation. Those are easy to implement. Basically, the algorithm that we're going to implement here is something that you have studied in your primary school. So we're going to use a method like that. Let me just write it down in terms of an example, just to say that this is nothing new for you. So for example, if I say that we're going to find the let's say I want to find the GCD of 54 and 16. Okay, how do we do that? We take one of these numbers, like you can take 16 and try to divide 54 with that. How many times can you do this? What's going to be the result? 3 times, right? And that gives you how much? 42. So what's left? Sorry. That was silly. Okay, so yeah, 48. And then you have 6 left, right? So what do? Next time around, we compute the same thing over again. So this is one part. And this is where we bring down the 16 to carry out the same operation. How many times can you divide 16 with 6? 2 times. So you get 12. Then we have how much left? So we bring down 6 again. And then we can divide it only once. So what's the remainder? 2. And then you have 4. So 2 times 2, that's 4. There is no remainder. And this is when we know that the GCD is how much? GCD is 2. When you can fully divide a number by the divisor, that's when you stop and say that this is the GCD. So our final result is this. But what you need to understand is how this whole thing works. That this divisor will come over here, this divisor will come over here. It's a repeated process which is pretty much the same. You do the same thing over and over again till you have to stop. So this is something we have done in primary school, and we just need to write a program. And it's easily done with recursion. If you have studied recursion already, you can do it recursively. You can also do it with a while loop. I mean, you don't have to pull recursion for that. So if you find recursion easy to understand, do it recursively. If you don't, do it with a while loop. No big deal. One thing that I just wanted to make sure if you understand it right. We are trying to divide 54 with 16. Would it be okay if I tried to do it the other way around? Is it necessary to find out which number is smaller or not? If I try to divide 16 with 54, would it still work? Turns out it would still be the same. It would still work. And how does it happen? Let's say I take 54 as a divisor, How many times can we divide 16 with 54? 0 times. We can't divide, right? So 0 times 54 is what? 0. So what am I left with? 16 as remainder, and then it becomes the same thing. So it doesn't really matter whether you take the smaller number first or not. It's going to boil down to the same thing, one extra step. So it should happen automatically. Okay. So if you know how to do this, in our problem what we have is 9 and 36, which is a really easy example, because now 4 times 9 is 36, so there is 0 left. That tells you that 9 is the GCD. So we stop right there. Once we know which is the GCD, we just use that to divide both the numerator and the denominator to reduce the number. So that's the reduction thing. Multiply, subtract, and reduce. For the complex number class, I want you to try these two things out, the multiply and divide. Okay? And for that, maybe you forgot how to do it, you forgot the formula and the proper process. The search on Google, I think we have it on it, right? It's not shut down right now, so use that to full effect. Look for examples, try to understand how this is done, and try to implement at least multiply if you can do divide. If possible, do both of them. And let us take like till 12:30. Right now it's 11:53. Let's take till 12:30 to get it done. After that, I will do my implementation. I need some time for that, right? I can do some of these methods so that if you got stuck with something, you can look that up. So again, for those of you, if you're lost, I mean, this is where you have to write code. We have the add and subtract written. You need to add new methods. For example, if you're going to write multiply, it's going to be public rational number multiply as parameter you pass rational number b. So it's going to be a very similar pattern for the other methods. Reduce is going to be a little bit different, but you will probably be able to figure that out. Okay, so I'm going to pause the video and I'm going to do a few of these things. Well, for rational number, things are quite easy, like the multiply and divide. Those methods are pretty straightforward, so you can pretty much copy paste stuff. For the multiply method, the way we multiply two rational numbers, let's say we got 2 divided by 5 into 6 divided by 3, well, something like that. 6 divided by 5 or something as such. Multiplying this means you multiply the numerator with numerator, so this is going to be 12, and down here it's going to be 25. Okay. It's as simple as that. If it is divide, then also it's not going to be that difficult. It's just that in this case you have to treat it as a multiply. Of 5 divided by 6, then it's the same thing, right? So we can actually write one method and then use the same method to do the other task. How so? For multiplication, it's just going to be a's numerator times b's numerator, and a's denominator times b's denominator. So we have done that. So that's one part. And we can similarly do the divide thing. Okay, so we could do divide over here. It's just that for number b, things would be different. See, number b gets turned over. So you say b's denominator gets multiplied with a's numerator, and b's numerator gets multiplied with a's denominator. So that's the thing. And probably you can most of you have done it this way. That's why I'm going to do it in a slightly different way. We can simply write this method as this dot multiply new rational number. You take b's numerator, actually b's denominator, and b's numerator, and that would mean the same thing. It's just that don't we have rational number? Yeah, we do have that. Okay, all right. Probably I spelled it wrong. So that's the thing. I mean, do you guys understand how we can write it in one line like this? We are trying to do the division operation, and I'm saying that division is just the same as multiplication. So if you need to divide 2 divided by 5 by 6 divided by 5, you can actually do the multiplication if the number given to you was turned over like this. Instead of 6 by 5, you need 5 by 6. So we are given b as 6 by 5. What we can do now is to create a new rational number where we pass b's denominator as the numerator and b's numerator as the denominator. So this way, I can use my existing code to do the task. Or I could just write it in this way. No big deal. Just wanted to show you that there are more than one ways to do the same thing, and probably this is easier. Okay. So that's that. For the reduce method, you can either do a while loop or you can also use recursion to reduce it. So we can have something like a private void reduce. This method is supposed to reduce the numbers by dividing both the numerator and the denominator. Okay, so let me just give you an example how this may work. Let's say the divisor is 1. We're going to do like numerator equal to numerator, whatever the numerator is, divided by the divisor. And we're going to do the same thing for the denominator. By dividing it by the divisors. Okay. And we can leave this method as private if we want that other methods would call this. If you don't want that, then you'd have to make it public so that you can call it from other places. So what I mean by this is that let's say we do the multiply operation, or we do the subtract, or we do the add. Before returning these things, we can just call reduce to have it reduced. If reduce is working properly, then we can call reduce to have it reduce just like that. Or we could even save this call and leave it on the constructor to deal with that. See, we are constructing an object. So when we pass these numbers, right after that, we can call reduce so that it gets reduced. Now let me show you a quick example right here. This reduce method, I don't really know what this divisor is going to be. So let me just assume that the divisor is going to be 2, which is a very bad example, but this would do for now. So 10 by 3, we got this number. If we had 10 by 6, then it would definitely work properly. See, what we got is 5 divided by 3. How did that work? Right after constructing, it divided both the numerator and the denominator by 2, because we set 2 to be a fixed number that we divide with. So this next number, 2 divided by 3, it became 1 divided by 1, which is wrong. So instead of passing 2 as a divisor, which is not going to work in all the cases, we need to pass the GCD. That's the idea. Since we're calling this constructor every single time we do something over here, it would ensure that the reduce method would get called. However, we need to make sure that this is happening. Okay. How many of you got the GCD done? Only you. So only Onyx. So and you did that with recursion. Okay. So let me go with the other way around for this. Try to do it in a different way. So if you notice, what are the things that are happening? Let me put some labels over here so that we can track and how we can write some code to implement the same idea. Let me use a different color. So let's say we got number A and number B. We will keep on dividing till what? Till B divided by A leaves us no remainder. That's what we are going to do, right? It's going to happen till that point. So if you wanted to write code looking at that example, what can we do? Say by default the divisor is 1, and over here we got A equal to either the numerator or the denominator, doesn't matter, because they will switch. If one is less than the other, they will automatically switch, right? So let us say we have long A equal to the numerator, long B equal to the denominator, and now I can say while this is not true, keep on doing this, while B mod A not equal to 0, keep on doing whatever we say that you have to do. Okay, so it's going to keep on repeating. And how do I know this? See, this is where, if this is A and this is B, B mod A is equal to 0, and that's the point where I should stop. If that's not happening, what's going to happen internally? Let us just look at it. What is going to be the scenario in the next step? What do we have? How do we get the 6? This is going to be the remainder of B divided by A. So B mod A will give you this number, and this is actually what? The divisor. And we call the divisor as A. What's going to be this thing? This is actually what we had as A, but this time this is going to be B. So they're changing their role, right? I want to write code in a simple way. I want to make things really simple. So let's say I have two things. First of all, I want to call this X, and I want to call this one Y. And there is a good reason for that. I'll explain in a bit. So how do we get X? Like we figured out, B mod A, that's X. How do we get Y? Y is nothing but A. Alright, you can see that. 16 comes over here without any change, so that's that. Okay? So after we do this, in the next step, what happens? This X is actually A, and this Y is B. So you just write that. Okay. So what's the reason? Why did I do it in this fashion? Why did I not write directly that A is equal to B mod A and B is equal to A? Why did I not do that? Because that's essentially what's happening, right? B mod A gets assigned to X, and that's what I put down as A, and this A gets assigned to Y, and then I put it into B. So why not write it in this way? Because this step would change the value of A, and then you're going to use the changed value over here. Okay? So there is a dependence. These two things are dependent, and you can't do that. That's why I've saved them in a temporary variable, then I copied them over. That's how this needs to be done in this way. If you're writing this with recursion, things are a little bit simpler there. You don't have to worry about it because they get copied over into another function through different names. Okay, so my code is a little bit longer than what you'd write in recursion. It's a little bit simpler that way, but I wanted to try it out just like that. So now that we have done this part, what's our GCD? After doing all these things, what's going to be the GCD? And the answer to that is right over here. Once you're done dividing through all these steps, your GCD is right here. Whatever you have as the value of A is your GCD. So what we can do now is take this line and put it down here to say that GCD is not 1, it's not 2, it is whatever we have in A. And that's it. So that's our reduce method. Okay. So if you run this project now, hopefully things would be okay, which it's not. And I have done something really wrong right now. B mod A not equal 0. I'm trying to divide by 0, which is really weird. Let me track this. This is 64. Do we have 0 as numerator anywhere? 10 and 6, 2 and 3. Okay, so me failing at this gives me an opportunity to show you how to properly debug stuff. NetBeans is really good for that. See, I have a problem over here in this line, right? I need to find out why this is not working. So what I do is I place something called a breakpoint. My program will stop when it comes to this point. How do I do it? Just click over here. Okay, finally. So if you click on the line number right there, it inserts a breakpoint for you. Okay. So once you have a breakpoint, you can debug your code. If you click here, the debug project. So your code is going to come to that point, to the reduce point, and it will stop right there because this is where we have a breakpoint. And the interesting thing is you can actually track all the variables, all the values that you have set. So right now, what does it show you? 10 and 6. And then we go to the next step. Okay, so we can step over, it goes to the next line. So now we find A equal to 10. Right here says A equal to 10. Then the next line, if you debug this again, so we have 10 and 6, and now B mod A not equal to 0. Is this true? So 10 divide, what's this? 6 mod 10 not equal 0. Is this true? Yes, that's true. So we get long X equal to B mod A. So X becomes 6 and Y becomes 10. So now we got A equal to X, which is A equal to 6 and B equal to 10, and that's oh, how silly of me. I was just showing you that this is something you cannot do, and that's exactly what I did. My code should have stopped there. I have introduced the temporary variables over here, and those are the code that I was just talking about it, and I just wrote it down. And you cannot write it in that way, so you should avoid that. So now I've figured that out by tracking like what are the values I got, and it should work. Hopefully this time around. Yes, it does. So 5 by 3 plus 2 by 3 is 7 by 3 blocks. So previously we had a multiplied value, like 3 times 3 we had 9. Now these are getting reduced in a proper way. Is this thing clear? Okay. So unfortunately I ran out of time. I made a mistake myself. The point that I wanted you to understand is the other thing. For the complex numbers, things are a little bit complex. I mean, for rational number, you just multiply the numerator with the numerator, the denominator with the denominator. However, when you go for the complex number, let us just take a really simple example. I'm not going to waste too much time. Let's say we got 2 plus 4i, and with that, we are going to multiply another number, say 4 plus 1i. Let's not keep it that simple. It's too simple for my case. This would do. Let's say 4 plus 5i. Or we can have negative numbers even. So how do we carry out this operation? In order to understand that, you have to follow the law of distribution. So if you had a number written like this, a plus b multiplied by, say, c plus d, how do you carry out this multiplication? This is going to be AC plus AD plus BC plus BD. So the same thing going to happen over here. 2 into 4, which is 8, plus 2 into 5i, that's going to be 10i. And up here we got 16i, and then 4 times 5, that's 20, 20i square, and that's the fun part. So when you have I square, that means since this is minus 1, if you square that, what do you get? You get just minus 1. There is no I is gone. Okay, so right over here this is going to be 20, and up here we got how much? 8. They don't have any I part with them, so you can actually add them up. And over here we got 10 and 16 with i's. You can add those two numbers. That's going to be 26 I. So the point I wanted to understand, when you carry out the multiplication of two complex numbers, mathematically this is the real part times the real part, and then minus the imaginary part times the imaginary part. So this is what we did, right? So that's one thing. And as for the imaginary part, real of this one times the imaginary of this one, plus the imaginary over here times the real over here. So that way you can write the complex number. It's going to be very similar, but you need to figure out what's happening. For the division operation, it's again a little bit more complicated. You have to find out the conjugate number that can be multiplied on both the top part and the bottom part, so that you have no I squared to start with. So for example, if I want to divide with something, this number divided by this, I will come up with the conjugate of this. And the conjugate is going to be 4 minus 5i. Why do we pick that number? So that we can get rid of I altogether. That means we have, if you have a plus b times a minus b, the product is going to be a square minus b square. And square is a nice thing to get rid of the I. So if you have 4 plus 5i over here, 4 plus 5i like this. If you multiply this with 4 minus 5i, what's going to happen? This is in the form a plus b times a minus b. So you get 16, 4 times 4, a square, minus b square, and minus, what's this? 5i whole square. So this is essentially 16 plus 25. Why plus? Because I squared is minus 1. Okay, so once you find this number, this is not a complex number anymore. When you multiply with the conjugate, you don't get a complex number, and that's what you use for division. You divide both the real part and the imaginary part by this conjugate number. So go and look up how this is done in your math course. And once you figure that idea, you just need to write a Java program, which is not too difficult. Unfortunately, I didn't get time to do this complex thing. Please finish this off as your homework. I can also upload the code, the finished version, but I want you to try it out yourself first. Did you guys understand all these things? Please make sure that you do them at home as well. That's going to be a good exercise for what you can expect in your midterm exam. It's not going to be the same, but it would be something similar. Okay, alright, that's pretty much it then. I'm going to finish recording, upload the code and the video, whatever we got.